I'm sure you've seen the pictures, right? A beach that looks like the entire night sky just fell into the ocean, with these waves glowing in electric blue. It's the Maldives' famous Sea of Stars. But behind this totally magical image, there's a wild story of microscopic survival, ancient folklore, and some really cool biochemistry. Okay, let's dive into this and uncover the reality behind one of nature's most absolutely dazzling light shows. For centuries, way before marine biology could give us an explanation, the Maldivian people had their own. They called this thing Redhan loon, and their folklore paints this beautiful picture of stars just falling from the heavens to the sea. You can imagine, it was seen as a powerful omen, a direct connection between the cosmos and the ocean.
So, that's our big question here. Are we looking at a fairy tale come to life, or is this glow actually a desperate, high-stakes defense mechanism playing out trillions of times in a single wave? The answer, as we're about to find out, is, well, it's a little bit of both.
To really get that answer, we've got to start with the science. We need to understand the biological engine that's driving all this light.
The phenomenon is called bioluminescence. Now, the key term here is cold light, and this is crucial. Think about it. These tiny organisms are producing light with incredible efficiency. If they were as inefficient as an old incandescent light bulb, the heat from a big group of them could literally cook themselves. So this is a vital survival adaptation.
And the master electricians behind this whole spectacle? They're microscopic plankton called dinoflagellates. Now, there are a lot of different types, but the main one creating the Sea of Stars is called Noctiluca scintillans. These are the tiny, living lanterns of the ocean.
So, how in the world do they do it? It's a super fast chain reaction. First, something has to disturb them. A wave, a fish, even your foot in the sand. This physical stress sends a signal, flooding these tiny compartments inside the cell with calcium ions. That causes the pH to drop, which acts like an on switch for an enzyme called luciferase. The enzyme then instantly oxidizes a fuel-like pigment called luciferin, and just like that, energy is released as a flash of blue light. It happens in an instant.
This table breaks down the key players perfectly. You've got luciferin as the fuel, luciferase as the engine, and calcium ions as the trigger. It's this perfectly contained, highly effective biological security system. Now let's see how this system turns into an amazing survival strategy.
Because this isn't just for show. Oh no. This intense, beautiful light serves a very clever, and actually, a pretty deadly purpose.
So here's the deal. The glow isn't just pretty, it's a weapon, and it's used in one of the most brilliant defense strategies in the ocean, all explained by the burglar alarm hypothesis. Just imagine a tiny predator swimming in the dark. It finds one of these dinoflagellates and goes in for the kill. The moment it attacks, the plankton screams with light. That sudden flash not only startles the attacker, it paints a giant neon target on its back. Suddenly, the hunter becomes the hunted, lit up for any bigger fish to see and gobble up. The plankton basically sacrifices itself to call in an airstrike on its own attacker. It's a stunning, high-stakes evolutionary gamble that helps ensure its killer gets taken out. But this incredible alarm system is only switched on at night. The dinoflagellates run on a strict internal clock, a circadian rhythm, just like we do. During the day, they're busy with other stuff, like photosynthesis, and the glowing mechanism is actually turned off. The light show only starts after the sun goes down.
Okay, so now you know the science. You're probably thinking, I have to see this for myself. Well, you can, but it's not quite as simple as just booking a ticket to the Maldives. There are a few things you need to know.
First off, and this is so critical for any travel planning, there are 2 islands named Vaadhoo in the Maldives. The one you want for the famous Sea of Stars is in the Raa Atoll. The other Vaadhoo is almost 500 kilometers south and is known more for surfing. Getting this wrong could land you on the complete opposite end of the country from where you wanted to be. So, check your map.
Timing is also everything. As you can see here, your best chance of seeing a really spectacular display is from June to October. This lines up with the southwest monsoon, when the rains wash all these nutrients from the islands into the water. That fuels a massive population boom for the plankton. And more plankton, well, it means a lot more light. And here is your perfect recipe for success. You want the darkest sky possible, so a new moon is ideal. Warm water, somewhere between 27 and 30 degrees Celsius, gets the plankton more active. And here's a pro tip for you. Look for a red tide during the day. If the water has this kind of reddish-orange tint, it's a huge sign that it's packed with dinoflagellates, and that means you're in for a brilliant show that night. This natural wonder is just breathtaking, but it's also incredibly fragile. And, its growing popularity actually poses a direct threat to its existence.
The threats are coming from all over, both local and global. On a personal level, chemicals like oxybenzone in sunscreen are straight up toxic to the plankton. At the resort level, bright lights can totally mess with their internal clocks. And then on a global scale, you have things like microplastics and ocean acidification caused by rising CO2 levels, which threaten the very chemistry that lets them produce light in the first place.
But we can make a difference. The rules for being a responsible viewer are simple, but they're really powerful. Go into the water clean, no lotions, no repellents. Use a red light flashlight if you need one, because it's much less disruptive. And remember, you don't need to splash around like crazy. A gentle swirl of your hand or a slow walk is more than enough to ignite the magic.
And this brings us to our final thought here. The Sea of Stars is so much more than a tourist attraction. It's a sensitive barometer for the health of our oceans. As we face the realities of climate change and ocean acidification, we really have to ask ourselves, are we at risk of losing this magic? Will the ocean's most beautiful lights actually begin to fade?